continuing with question number 7. ABC is a triangle right angled at C. Okay, so remember this place is the angle C is equal to 90 degree, right? A line through the midpoint M of the hypotenuse and parallel to BC intersect AC at D. So remember, they're simply saying that this is a midpoint of AB and this line is parallel to BC, okay, and it meets the line AC at D, right? So that is what the question is saying, right? Now what are they asking us to prove? We're supposed to prove all this, okay? D is a midpoint of AC, MD is perpendicular AC, CM equals MA equals half times AB. So we'll go one after the other, right? So first let's write down the given. ABC is a right angle at C, M is a midpoint of AB, and MD is parallel to BC. Alright, so write down the proof, and then construction this construction will be used for the third proof, okay? Alright, now let's go to the proof. In right triangle ABC, like I said, they've already given us what? That this is a midpoint of AB, right? And also that MD is parallel to BC, which means will D be the midpoint of AC? It has to be, okay? So you can see here, therefore D is a midpoint of AC. Alright, so this is the converse of the midpoint theorem. Alright, now let's go to the next. So the second, I have to prove that MD is perpendicular to AC. Perpendicular means what? 90 degree, right? So I have to prove that this is 90 or this is 90. Okay. Alright, so now when you look here, can you see these two lines, MD and BC, right? Which means that AC becomes a transversal. Alright. Now, we already know that what angle C plus angle D should be equal to 180 degree. Why? Interior angles on the same side are supplementary. Okay, chapter 6. Alright. Now, can I say that angle C equals 90 degree? Already given from the question, right? They say this is a right angle at C, so this is 90. Now let's try to prove that this is 90. Okay, so angle D equals 180 degree, so this 90 will go to the other side. 180 degree minus 90, I'm going to get how much? 90 degree, right? Or that means what, we've already proved that angle D is 90. Okay, or in other words, we can take MDC, right? Angle MDC equals 90 degree. Therefore, can I say that MD is perpendicular to AC? It is perpendicular, right? MD is perpendicular to AC. Right, now let's go with the third proof here. We're supposed to prove CM equals MA equals half times AB. Okay, so we'll be considering these two triangles, right? This triangle and these two, the other triangle, this. But first let's try to prove that this and these triangles are congruent, or that they are equal. Clear? Now can I say AD equals CD? Can I say AD equals CD? We can say, right? Because remember, we've already proved that D is the midpoint, right? Also, can I say that angle ADM, right, equals CDM equals 90 degree? We have already proved that MD is perpendicular to AC, right? We can say that. The last, we can take what? MD to be the common side, right? They both share one common side, MD. So you can say MD equals MD, which will give us the common side. Okay, now can I say that these two triangles, this triangle and this triangle, are congruent, or that they are same or equal? Yeah, we can say it by the side congruency rule. Okay, now we know that this triangle and this triangle are equal. That means, can I say that what? AM equals CM. Remember, they're equal, right? So obviously these two sides should be also equal to one another, so they will give us the congruent parts of congruent triangles. Okay, now when you look at this AB here, right, can I say that AM, this is half times the whole length AB? We can say, right? Because remember, they already told us that what M is the midpoint of AB, which means this AM is half times AB. Okay, now from 1 and 2, right, from this equation 1 and 2, at 1 can you see that AM, right, which means even their right hand side has to be equal to one another, or this AM, CM, and half times AB, they are all equal to one another. Okay, there's how we'll get the proof. All right, CM equals AM equals half times AB, which is our proof here.